Today's lesson has to do with the Fundamental Theorem of Algebra. And to make it really simplified, what this theorem is stating is that if you have the highest power, let's say is 3, definitely you're going to have 3 roots. But out of those 3 roots, remember, they're saying that at least one of them will be a complex number. And basically that is the whole theorem of algebra. It's saying that for every polynomial function, there's at least one complex zero, and that for n, for a degree n, there's n amount of factors. So if we look at example A, it says, what are all the roots of x to the 5th minus x to the 4th minus 3x cubed plus 2x squared minus 4x plus 4? Well, you know that the highest power is 5. So there will be at least 5 roots, and that's what it's saying right there, 5 roots. And what we're trying to find are the zeros. And for us to figure out the possible zeros, we're going to go ahead and use what we used last time, the rational root theorem. So step 1, we need to go ahead and figure out what are the factors of the constant. In this case, it's 4, and we also need to make sure we can find the factors of the leading coefficient. The factors of 4 are going to be plus and minus 4, comma, plus and minus 2, comma, plus or minus 1, divided by our leading term is 1, so it's going to be plus and minus 1. So when you divide this, 1 divided by 1, you're going to get plus or minus 1. 2 divided by 1 is 2 plus or minus 2. And then plus or minus 4 divided by plus or minus 1, which gives you plus or minus 4. So we're going to check which of these is going to be a possible zero or root. And so it says we're going to evaluate x equal 1, and we want to see if the remainder is 0. So let's go ahead and write 1, and we're checking if x minus 1 is a factor. How do we know if x minus 1 is a factor? So we're going to use synthetic division. We have 1, negative 1, negative 3, 3, negative 4, and 4. We're going to drop the 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. Negative 3 plus 0 is negative 3. 1 times negative 3 is negative 3. 3 minus 3 is 0. 1 times 0 is 0. Negative 4 times 0 is negative 4. Negative 4 plus 0 is negative 4. 1 times negative 4 is negative 4. 4 minus 4 is 0. And we notice that it is a factor. So we have x minus 1, and we're left with x to the 4th minus 3x squared minus 4. So we know that x minus 1 is a factor. Remember that the highest power is 5, so we have 1x to the 4th. We have 0x cubed minus 3x squared. We have 0x, and then we have minus 4 parentheses. So we have a quartic factor and we have a linear factor, and we can factor x to the 4th minus 3x squared minus 4. We have to find the factors of negative 4 that add up to give you negative 3. And so I'm going to write the linear factor. I'm going to write the linear factor x minus 1. We have x to the 2nd power minus 4 parentheses x squared plus 1 equals 0. So we have x minus 1 equals 0, x squared minus 4 equals 0, x squared plus 1 equals 0. Our next step is to set each factor equal to 0, and then we will solve for x. So we have x equals 1, since we're going to add 1 to both sides, and we get x equal 1. The next step is to add 4, and we have x squared equals 4. You get the square root of both sides, so you notice that your answer will be 2 and negative 2. And of course, the last one, we have x squared equals negative 1, and then you're going to have to get the square root of both sides. So you have x equals plus or minus I. That is a complex number. Remember, I told you that comes in pairs. So that holds true to the fundamental theorem of algebra. The highest power was 5, and you have 5 answers. 1, 2, 3, 4, and 5. We have 1, 2, negative 2, positive I, and negative I. So in this part of example B, we're trying to find the zeros of this quartic polynomial. It says find the factored form, and then it says what are the zeros of f of x. And what they used was a graphing calculator. And so I want you to take a minute, take 60 seconds to observe and to look at both graphs. And you notice that we have zeros right there and we have a 0 right there. So automatically we know that there are going to be 4 roots or 4 zeros, and we already have 2 of them. And so what we want to do is we want to check and use synthetic division twice to find our remaining polynomial, since we've figured out that x plus 3 or x equals 3 is a root and x equal 3 is also a root. So what we're going to use synthetic division twice to figure out the remaining roots, and it should be a quadratic. So we have negative 3. And we're going to go ahead and list our coefficients. So we have 1, 1, negative 7, negative 9, negative 18. Remember, I'm using that function that was given to us on the very top. So we're using synthetic division to find our polynomial that we can use to find the remaining roots. So you bring down the 1. Negative 3 times 1 is negative 3. 1 plus negative 3 is negative 2. Negative 3 times negative 2 is positive 6. Negative 7 plus 6 gives you negative 1. Negative 3 times negative 1 is positive 3. Negative 9 plus 3 gives you negative 6. And so negative 3 times negative 6 is 18. And just like our graph showed, it is a root. It is a solution. So we're going to use the remaining polynomial. And so we're going to use 3 now. And we're going to list our coefficients: 1, negative 2, negative 1, and negative 6. And we're going to go ahead and figure out the polynomial, like we said earlier. That's going to give us the remaining 2 roots. So we have 1. 3 times 1 is 3. Negative 2 plus 3 is 1. 3 times 1 is 3. Negative 1 plus 3 is 2. 3 times 2 is 6. Negative 6 plus 6 is 0. And so our quadratic will be x squared plus x plus 2 equals 0. By just looking at the graph, we have two roots or 2 zeros. Then automatically that tells you that there's 2 other roots that are imaginary. We don't see it on the graph graphically because it's not crossing the x-axis. And they provided us the formula here. So I have x equals negative 1 plus or minus square root, and we have 1. And 4 times 2 is 8, so it's minus 8 divided by 2. And so we have negative 1 plus or minus square root of negative 7 divided by 2. Remember, this is a discriminant. And so we're going to check again. So we have negative 1 plus or minus 1 squared is 1. Minus 4 times 1 is 4 times 2 is 8. So 1 minus 8 is negative 7. And we know that negative 1, the square root of negative 1 is I. So it's going to be negative 1 plus or minus I square root of 7 divided by 2. And this is your complex conjugate. And I told you that they come in pairs. So we have 2 roots here or two zeros here, or I'm not saying zeros, but two solutions that will make this equal to 0. And then we have the other two answers, which are the two solutions, which are 3 and -3. Without using a calculator, find all the roots of the equation. We know that we have 3 right here. So that tells us we're going to have 3 roots because of the fundamental theorem of algebra. You have to find the factors of 3 and also find the factors of 1. And these are your possible roots. And we're going to use synthetic division to check which one could be a possible root. So we're going to go ahead and check -1. I just decided to use -1. So we have 1, -3, 1, -3. That's it, right? Okay, we're going to go ahead and bring down the 1. -1 times 1 is -1. -3 plus -1 is -4. -1 times -1, -4 is 4. 1 plus 4 is 5. That's -5. That's -8. That's not going to work. So -1 isn't is not a root. So we're going to go ahead and try 1. So we have 1, -3, 1, -3. Bring down the 1. 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 1 plus -2 is -1. 1 times -1 is -1, so that's -4. So that isn't an answer either. So now we're going to try 3. So we have 3, and I'm going to go ahead and move it over a little bit. Well, I'm going to have to try it down here. We have 3, so we have 1, -3, 1, -3. So we bring down the 1. 3 times 1 is 3. -3 plus 3 is 0. 3 times 0 is 0. 1 plus 0 is 1. 3 times 1 is 3. -3 plus 3 is 0. So we found the first factor, which is x minus 3. And our remaining factor is a quadratic, x squared plus 1. So our first factor was x minus 3, because we checked that was a remainder of 0. And then the second factor is x squared plus 1. So I'm going to solve x squared plus 1 equals 0. So we have x squared equals -1. Get the square root of both sides. So x equals plus or minus I, which this is, once again, it's a complex conjugate, and they do come in pairs. So that's 2 plus the real one, which is 3. So that's a total of 3 solutions, 3 roots. And so based on the fundamental theorem, we've already found the 3 roots, and then we can stop. So we're going to solve x to the 3rd power plus x squared plus 4x plus 4. So what we're going to have to do is use the theorem, rational root theorem, to figure out what are the possible answers, our possible roots. We have plus or minus 4, plus or minus 2, plus or minus 1 over, those are the factors of the constant. And our leading coefficient is 1, so it's plus or minus 1. So when you divide this, you're left with, these are the possible roots. So let's go ahead and try -1. And so we have 1, 1, 4, 4, x cubed, x squared, x, and a constant. And if our remainder is 0, then we know that x plus 1 is a factor. So we have 1. -1 times 1 is -1. 1 plus -1 is 0. Negative 1 times 0 is 0. 4 plus 0 is 4. Negative 1 times 4 is negative 4. 4 plus negative 4 is 0. So what does that tell us about x plus 1? It's a factor. So this is our remaining coefficient. So we have x squared. Of course, that's 0x plus 4 equals 0. And now we're going to go ahead and solve this. So we're going to set each factor equal to 0. So if we want to solve for x here, this is going to be negative 1. That's our first answer. X squared equals, let me take that back. X squared plus 4 equals 0. X squared equals negative 4. We're going to subtract 4 from both sides. So we get the square root of both sides. So x is equal to plus or minus 2, because the square root of 4 is 2, and I. And so this is your complex conjugate. They're imaginary answers. We have one that crosses the x-axis at negative 1, and then we have 2 other zeros that are imaginary for a total of 3, and that was our highest power. So the fundamental theorem holds. We have 3 answers, 2 of them that are imaginary. We're going to solve x to the 4th plus 4x cubed plus 7x squared plus 16x plus 12. And we have to figure out, once again, the factors of our constant. So we have plus or minus 12, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, plus or minus 1, divided by the constant that is the leading term, the coefficient of the leading term, so it's plus or minus 1. So our possible roots are plus or minus 12, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, and plus or minus 1. And what I'm going to do, I'm going to use my graphing calculator. I know it said no calculator, but I'm going to use my graphing calculator to kind of figure out which is going to be our root. So I'm going to try negative 3. So I have 1, 4, 7, 16, 12. 1 times negative 3 is negative 3. And right here, I'm using synthetic division. And I'm checking if negative 3 will be, it's actually x plus 3 is going to be a root. And if it's a remainder 0, then it is. 4 plus negative 3 is 1. Negative 3 times 1 is negative 3. 7 plus negative 3 is 4. Negative 3 times 4 is negative 12. 16 plus negative 12 is 4. Negative 3 times 4 is negative 12, so that's 0. So that tells us that x plus 3 is a factor. So now I'm going to try negative 1, and we're checking if x plus 1 is a factor. So we have negative 1. And our remaining polynomial has coefficients of 1, 1, 4, 4. Bring down the 1. Negative 1 times 1 is negative 1. 1 plus negative 1 is 0. Negative 1 times 1 is 0. 4 plus 0 is 4. Negative 1 times 4 is negative 4. 4 plus negative 4 is 0. That's a remainder. So x plus 1 is a factor. So you're left with our quadratic factor, which is x squared plus 4 equals 0. You set each factor equal to 0. Well, we know this is x equal 3, negative 3. This is x equal negative 1. So there's 2 roots there. So now we're going to solve x squared plus 4 equals 0. So you subtract 4 from both sides. So you have x squared equals negative 4 square root. So x equals plus or minus 2i. And this is your complex conjugate. So we know that our highest power is 4, and we do have 4 roots.